Hey guys, Pll Sfr here, and today we're going to be taking a look at another stress-tested 12900K overclock that I've set up here on the MSI Z690 UnifyX motherboard. Big thank you to MSI for providing the board, by the way. The memory kit that I'm using is the Gigabyte Aorus 16 gig SK Hynix DIMMs, so 32 gigs of memory of DDR5 in total. And then we have the 360 millimeter custom loop, so 360 millimeter radiator, and then EK Supremacy MX block. So that's a relatively old EK block, but the reason we're on this loop is because this is the water block that I use for like all liquid metal testing. So yeah, there is liquid metal between the IHS and the water block, and that's actually a really like a lot of people think that liquid metal only works in direct die applications, but actually it works really well in any application where you have a high thermal density, and a 12900K is very much that. So even on top of the IHS, the liquid metal actually helps a lot with temperatures, especially when you're running stress tests like Linpack Extreme. Also, we have this fan right here for cooling down the memory because Linpack Extreme does use the memory quite a lot, and the memory is not at XMP. It's not. I'd be surprised if the memory overclock didn't pass like a memory stress test at this point, considering how much Linpack it survived and Y-Cruncher. But it's not a memory overclock that I've like. The memory overclock is more of a placeholder than a actual like target. It's just some settings that I'm pretty sure will always work. Like I expect to work. Because the thing is with Linpack, if you run it with bad memory settings, it actually makes the stress test easier, so you can't really run it with terrible memory settings because it'll give you unrealistic results if you ever decide to overclock your memory afterwards. Anyway, so I think that's most of the setup. Yeah, we have the like fan for cooling the RAM, which also happens to cool the motherboard a bit, but that doesn't really matter with this board. And then, yeah, that's kind of it. I mean, unless you care about the GPU I'm using, which is just a GT 1030. So anyway, let's take a look at the settings. So the target stress test for this overclock is 100 loops of Linpack Extreme. And so here they are. I'm not sure why it's slowed down right here for some reason. Oh, I guess I must have been faffing around with some, like, window, like, moving stuff around on the system or something. It's probably why that happened, because yeah, the rest of it is all 646 to 647 G flops, and peak G flops was 648. All of the residual checks passed. You might notice that the residuals, like, they're not all the same, but the Linpack Extreme developer themselves said that basically when using AVX instructions, the residuals sometimes don't always, like, they're not always the same for some reason. I don't understand it myself. They sent me a link to a bunch of Intel documentation, and I just kind of gave up on reading that. Yeah, so, like, Linpack will, like, so the latest versions of Linpack Extreme, they'll, like, if it tells you it passed, it passed. So yeah, anyway, so that's 100 loops of Linpack Extreme, and that's with the CPU at 5.25 gigahertz on the P cores and 4.94 gigahertz on the ring. Also, it does run Y-Cruncher, right? Like Y-Cruncher 2.5 billion right there. That runs just fine. We can run it again. Y-Cruncher is actually slightly cooler running than Linpack. However, it does have slightly higher voltage requirements, which is kind of interesting. So I've tested both Linpack and Y-Cruncher because, yeah, the voltage is actually kind of set more for Y-Cruncher. I think the Y-Cruncher probably hits the ring harder than Linpack does. And so that's probably where because Y-Cruncher uses a lot more memory. Like Linpack, the data set size that I'm using is 10 gigs. And so actually the 100 loops of Linpack took 4,400 seconds to run. So over an hour of CPU running at 100% load. Admittedly, with temperature cycling, like Linpack does load cycle quite heavily. It doesn't just stay pegged at 100% CPU utilization. Well, It does. So the software will tell you it's at 100% CPU utilization, but the power draw changes because depending, like there's periods of time when Linpack is sort of putting the data set into the memory, and then there's the time when it actually does math. So when it's doing math, it's very, very hot. And when it's just putting stuff into memory, I mean, it is still loading the CPU quite a bit, but it's not anywhere near as hot. Anyway, yeah, so Y-Cruncher runs, Linpack runs, and this level of stability is actually sort of what I aim for with like my personal system. This will not run Prime 95 small FFTs, which is also true of my personal system. It will not run Prime 95 small FFTs either. Now, obviously, if you're, hell-bent on just 100% uptime and you have a system where any kind of crash is totally unacceptable, then yeah, I would recommend that you do stress test with Prime 95 small FFTs because there's really nothing that that's as heavy as Prime 95 small FFTs for 12th gen CPUs, because Prime 95 small FFTs uses AVX instructions, and also it runs entirely out of the L3 cache of the CPU. So unlike Linpack, which is very heavy, and Y-Cruncher, which is also very heavy, because Prime 95 runs entirely out of the L3 cache, it doesn't get like stalled out waiting for memory access, and so it reaches much higher peak power draws. Though interestingly enough, there are some CPUs where that is not the case, as in I've seen higher peak power draw from Linpack on, I think it's Ryzen 5000 series, where Linpack just runs insanely hot. And Prime 95 is actually not that bad, but yeah, that's like architecture things. With 12th gen, Prime 95 is the hardest stress test I've run into. So yeah, or at least like that's the hardest stress test I'm aware of. So anyway, yeah, so 5.25 on the P core, on all of the P cores, and that's just locked in. That'll be at 5.25 all the time, and then the ring is at 4.94. So a very heavy ring overclock, which is possible because I don't have the E-cores turned on. If you have the E-cores turned on, the ring is probably gonna, depends on your CPU, but you're probably gonna be somewhere around 4.4 gigahertz on that. Anyway, even with the liquid metal and the giant 360 millimeter, well, it's not giant, there's bigger custom loops out there, but the thing is, like, a 360 millimeter radiator with the fans that I'm running on there, those fans go up to 2000 RPM. Actually, they go up to 2200. They're quite loud, and they do max out when running Linpack. We have a lot more radiator capacity than is really necessary for something like a 12900K with just the P-cores enabled, but the thing is the heat density is really high. So even with the liquid metal, the CPU did manage to, max out at 100 degrees Celsius, but that's still below like the thermal throttling threshold. So yeah, and I mean, if we ran Prime 95, then it would overheat and crash very quickly, but I'm happy with this. Like, I would totally daily this kind of overclock right here, because that's literally basically what I already do, right? Anyway, we're going to look at there's not really much point looking at the voltage settings here. Also, you'll notice hardware info's been open for 202 hours, because I'd set this up like ages ago and then just kind of didn't get around to recording the video for a while. Anyway, where was I going with this? Yeah, so that's the overclock. I guess let's run some Cinebench so you get an idea of how this performs. It's fast. Like, I love 12th gen, or more like, I love the P-cores. I think the E-cores are completely stupid, but the P-cores are freaking amazing, because you can have an 8-core CPU that spits out, like, higher Cinebench scores than a 10-core Comet Lake. Actually, like, this is approaching the territory of a 16-core Ryzen with just 8 cores. So, yeah, to me, this is just absolutely amazing. Though you do need a hell of a lot of cooling. Because this CPU, when I was testing it on an AIO cooler, I couldn't get it above 5.2 gigahertz for Cinebench. And now it does Linpack at 5.25. So, yeah, the big custom loop is and the liquid metal. Like, the thing is, the liquid metal does make a surprisingly big difference on a CPU like this. So, yeah. It's not just the custom loop, because the biggest, like, custom loops have two advantages over AIOs. One, because you can use a much bigger radiator, the, like, equilibrium temperature for the water is going to be a lot lower. And they also have a much higher water flow rate through the water block. So the heat gets actually pulled out of the thermal paste, really, because, well, I guess like the heat gets pulled out of the water block a lot faster because you have a higher water flow rate. However, if you're just doing like quick short tests, that shouldn't really affect the results too much in terms of running like, well, Cinebench, because Cinebench really isn't a very long test. So if you just leave the AIO sitting, like the closed loop cooler sitting for a while so that it cools down to room temperature, and then you run Cinebench and it still crashes, then that's kind of where it's like, yeah, the custom loop with the liquid metal does help a lot. So yeah, anyway, there's the Cinebench score. 8,000, almost 8,400 points. Nothing to complain about right there. That's well over 1,000 points per core. Yeah, and well, we could run. Should we run Geekbench? Oh no, that's the installer. Screw it. We're not going to run that. So we are now just going to go, yes, I'd like to leave. So now we're just going to go straight to the BIOS, and I'm actually going to show you the settings to get this stable here. So yeah. I'm kind of worried that like I'll have to rerun the stress test if I screw up anything in the video at this point. So anyway, let's restart. Boot right up. Yep, there we go. Hello, capture card? Are you kidding me? Oh, you've got to be kidding me. There we go. Man, I was really worried the capture card just randomly decided that it wouldn't cooperate. Anyway, so here's the actual settings. You'll notice I have the P-core ratio at 51. There's a annoying bug on 12th gen CPUs where basically you can't run more than the 51 ratio for AVX workloads. If you try to run, and when I say AVX workloads, I mean heavy AVX workloads. So like 53 multiplier works just fine for something like Cinebench for R20. But if you punch in like 53 and then try to run Linpack, it'll downclock to 51. Or if you punch in 52 and try to run Linpack, it'll downclock to 51. Yeah, so that's like not cool in my opinion. That's like the CPU, like, yeah, especially since it's a K CPU, like it shouldn't do that at all, but ultimately, it's not much of an issue because with 12th gen CPUs, the BCLK is completely separate from everything. Well, it affects your memory clocks, it affects your ring clock, it affects your CPU clock, but it doesn't affect your PCIe or SATA or USB ports or anything like that. So there's really no harm in running like a raised BCLK. Also, if you're like trying to get some really awkward mid-step frequency, like if your CPU can't quite do 5.3, but 5.2 is easy, well, you can do 5.25 by running a raised BCLK. Same kind of thing goes for the ring ratio, though I'd say like in order of priority, P-cores take priority over ring ratio. Like this won't run. This is at like over 5 gigahertz ring ratio is not stable with this CPU. Maybe like 4.977 or something would be, but that's like not worth losing the core clock. So 4.894 on the ring is fine because the ring has less of an impact on the overall CPU performance than the actual ring ratio. So you want to max out your CPU frequency, and then just whatever ring you can actually do is whatever ring you kind of go with. Anyway, the memory's at 6600-ish, so yeah, it's just a placeholder memory overclock so that Linpack is running at realistic levels of load. Yeah, you can actually, no, that's not even that it's not optimized. That's because I just have the timing set differently. This is relatively tight, actually, what I have here. Yeah, it just doesn't look like it because there's a bunch of auto everywhere. But anyway, let's talk about the voltage settings because we're not here for the memory overclock. We're here for the CPU. So digital all power. Mode 6 LLC gives a reasonable amount of V-droop. like, the thing is, mode 5 would just make the CPU overheat. So mode 6, I've not taken the oscilloscope to this motherboard yet, so I don't know what LLCs are like viable for overclocking. Well, viable for for really high stability requirements of overclocking, because it's kind of the thing is, like, if you're just running, like, because Cinebench is a relatively easy load, you can get away with questionably high levels of load line calibration. But anyway, so yeah, for something daily like this, mode 6 is like, this has a lot of E-droop to it, but it seems like the thing is, worse, like, you can't really have too much V-droop in like a safety sort of from a safety perspective. Like, if you have more V-droop than absolutely necessary to get good transient response, that's fine. It's not going to make your transient response worse. Whereas if you don't have enough V-droop, you're potentially making your CPU run a lot hotter than is absolutely necessary. And so with mode 6, idle is at 1.405 volts, so that's a perfectly dailyable core voltage for 24/7 usage. So I have no concerns about the core voltage that I'm running here, and so I really don't see a reason to try to set this up with mode 5, mode 4, or like a higher LLC, because there's really no downside to just being on mode 6 that I can immediately see, because like I have I don't have thermal headroom. I like, there's no reason. I like, the voltage is low enough to be safe, and I don't have thermal headroom to run a more aggressive LLC. Anyway, overvoltage protection is maxed out, of course. Overcurrent protection is on enhanced, which I wish there was a disable button, but actually it's probably for the best that there isn't a disable for the overcurrent protection. Switching frequency at 600 kilohertz. Now, the switching frequency on this motherboard changes your voltage, your load voltage. So if you're changing the switching frequency on a UnifyX, and like, it's fundamentally changing what core voltage you're getting, like, drastically. I don't know why. It shouldn't do that. It's super weird. The switching frequency really should have no effect whatsoever on your, like, voltage settings, but it does. So if you go from 500 kilohertz to 600 kilohertz, it gives you it basically seems to make the load line less steep. So you get less V-droop as you increase switching frequency, which is super weird. Like, that really shouldn't be happening. Anyway, once you get up to like 1,000 kilohertz, the effect is really, really significant. And I like, at 1,000 like, honestly, the board seems to be weak. Like, I messed around with 800 kilohertz, 900 kilohertz, 1,000 kilohertz. Wasn't great. So ultimately, I settled for 600 kilohertz, because that's where I could get a balance of, like, I have the V-droop I want, the voltage is behaving the way I want, and that's kind of that. So yeah, so normally you would want to set the switching frequency based on what gives you the best transient response, but because this board actively changes the voltage behavior, like DC voltage behavior, it's not like, I'm not talking about, transient here. I'm talking about, like, average voltage goes up as you change switching frequency, which makes zero sense. Like, that shouldn't be happening, but it does. And so, yeah, anyway, for now I've settled with 600 kilohertz, and, like, it's stable, not really too concerned about it, but it is super weird, and it is something that I'd like to investigate, but I can't without an oscilloscope hooked up, so... yeah, anyway, over temperature protections on auto, there's really no reason to change that. I think on auto, it's actually at 105 degrees Celsius or something, which is a perfectly reasonable VRM over temperature protection. And the auxiliary VRM load line is on auto because the memory overclock is a placeholder, and I'm not too worried about it. Anyway, so the core voltage is at 1.405 volts, which is fine for stability or long-term use. And under load, the voltage dips down into, I think, the low 1.3 volts-ish range. And that's perfectly, like, that's fine, right? Like, that's kind of the thing where I'm like, yeah, I can't cool more voltage than this, is because if I raise the voltage any higher, the CPU just, like, it already hits 100 degrees running Linpack, so there really isn't any voltage headroom left. So 1.44-ish idle voltage is fine, and then the load voltage dips down to match the cooling capabilities that, I have with this custom loop. along with the liquid metal. We can't forget the liquid metal. Like, you really can't. Anyway, system agent voltage is at 1.3 volts. The system agent voltage can slightly affect your ring stability. But yeah, 1.3 volts. MSI is turning that red, but I wouldn't be concerned about 1.3 volts system agent voltage whatsoever. VDDQ at 1.35, VDD2 at 1.4. I mean, at this point, we're looking at basically, well, memory voltages, so 1.45, 1.435 for the memory volts. And this is not minimized. It's just whatever, you know, like I don't want the memory overclock to crash. So I was just kind of, that's the memory voltage setting for these DIMMs on this board maxed out. Anyway, PLL voltages. So the CPU PLL SFR voltage, this can help with stabilizing high CPU frequencies. And so I have that set at 1.11. And I'd be, which is about as high as I'd be willing to set that for long-term use. I wouldn't set it any higher than this. Also, the board actually won't let you, but yeah, so that, like, stock is 0.9 volts. I wouldn't go more than a 200 millivolt offset, which this is technically 210. But yeah, like, that's still close enough to 200 that it should be fine. So I'm not too worried about that. Ring PLL can, again, this can help with ring stability as well as memory stability. So that's just raised by 60 millivolts. SA PLL is raised by 90, because default is 900. Yeah. If like I set these to auto, they default to 900. Anyway, so 90 millivolts on the PLL, and then the MC PLL is at 1.05, which is 150 millivolts, and yeah, that just helps. That can help with memory stability, as well as ring stability. So, yeah, that's kind of it for the settings. Like, CPU overclocking is relatively simple. You know, you just need enough cooling for whatever like, you basically just need to set the voltage high enough so that that you don't overheat and you have enough voltage for the frequency you're trying to run. And obviously, you have enough cooling for the frequency you're trying to run. So, yeah, basically, also this 12900K that I have is slightly below average for silicon quality. So, you should, like, I would imagine a lot of well, I don't know that a lot of CPUs, because the funny thing about silicon, like, well, off the top of my head, I do have some binning statistics for 12th gen. There's a lot of CPUs that are very close to average, and then there's, like, some extreme outliers. And there's, like, a lot of CPUs that are terrible. Right? Like, there's, like, yeah. So there's a lot of CPUs grouped really close together around the average that aren't really that much better. But mine is slightly below average. Maybe you know, like, definitely a 5.3 gigahertz Linpack is doable. I think there's probably some CPUs that can do a 5.4 for Linpack on all the P cores, but yeah, this is not one of those. This is completely maxed out. It will not go higher. I've tried. I've also, like, this is actually very similar to the settings that I ended up with on the Tachyon, because I tried to do this on the Tachyon as well, like max frequency for Linpack, and it was basically the same thing. I couldn't go over 5.25 gigahertz because the CPU would just get entirely too hot at some point. Oh yeah, the last thing worth noting with this board specifically is that on this BIOS version, which I'm using right here, is, oh man, okay, don't try to use the mouse in the BIOS. Anyway, this is BIOS version A22, and the microcode, well, with A22, there's the option to enable AVX 512. If you're setting up a daily overclock on a 12th gen CPU, use AVX 256, because AVX 512, for some reason, runs less hot than AVX 256 does. And so if you're stress testing with AVX 512 is actually easier than stress testing with AVX 256. However, if you run a piece of software that's AVX 256 accelerated and doesn't use AVX 512 at all, and it's really heavy, and you've only stress tested for AVX 512, you might crash out of, like, you know, for no reason, because you didn't stress test with AVX 256. So you should stress test with AVX 256, in my opinion, because it is harder to run than AVX 512, which is super weird. Like, 12th gen is, like, the only CPUs where that is the case, as far as I know. On, like, any other Intel chip, AVX 512 is absolutely infernal. And then 12th gen, for some reason, it lights... It's not like it's cold, okay? It's still really hot, but it is slightly cooler than AVX 256. So yeah, but after you've stress tested, you would actually potentially want to re-enable AVX 512 because it does give you a nice performance bump in anything that's AVX 512 accelerated gets a lot faster, with the exception of Linpack Extreme, which gets slightly slower for some reason. Probably not ideally optimized for 12th gen, though like Y-Cruncher gets a lot faster. So yeah, anyway, that's basically everything I wanted to cover in this video, is just kind of, yeah, I mean, the previous 12900K overclocking video was with Prime 95 small FFTs. It maxed out at 5.15 gigahertz. And if you just go for something like Linpack stability, 100 loops of Linpack, as well as Y-Cruncher, it's 5.25. You just need a hell of a lot of cooling. I mean, if you had a better quality CPU, you could probably get away, run similar settings at lower voltage with less cooling, but yeah, with this chip, this is basically the limit for this level of stability. So yeah, that's everything I wanted to cover in this video at this point. And hopefully this is somewhat helpful if you have a UnifyX or a Unify, because the regular Unify, actually the Ace board uses the same VRM as well, right? Which if you were wondering about voltage and VRM settings, then Ace, UnifyX, they all use the same VRM, so they should behave very similarly when it comes to configuring a 12th gen P cores only overclock like I have here. And then, the main difference is going to be depending on your cooling system. You're probably not going to be able to run as much voltage. And then depending on your silicon depending on your silicon quality, you might be able to run higher frequencies or lower frequencies. So that's kind of that. End of video. So thank you for watching. Thank you to MSI for providing the motherboard. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, hoodies, the usual YouTuber merch. Both Patreon and Teespring help out immensely with running the channel, so it would be much appreciated if you check them out. The links to them down in the description. And yeah, that's it for the video. So thanks for watching, and goodbye.